Hello and welcome back. In this video, I'm going to go over the new LyCORIS modules for LoRA, which are more commonly known as LoCon and LoHa. I'll start with the list of tools you'll need, then go over a high-level overview of how LoCon and LoHa works. My understanding of this is not that deep and possibly flawed, but I think it's invaluable to at least try to grasp what's going on under the hood. Afterwards, I'll be trying out training style on the redjuice style dataset I created in the previous LoRA video using both LyCORIS methods. Once the experiments conclude and the epoch versus weight grids analyzed, I'll start training a brand new dataset using the best experimental hyperparameters from the preceding experiments as a starting guide. Once that's done, I'll give my final thoughts about the LyCORIS modules. If any of these topics sounds like something you're interested in, let's dive in. Before we get started, you'll need a few things, some of which you'll already be familiar with if you watched the first video I created about LoRA for style. For this video, I'll be using the up-to-date local graphical user interface called Koya SS, created by bMalte and not the Google Colab notebook. Also, once you finish training, you'll need to install this extension by Kohaku Blueleaf in your automatic 1111 repository, or else you won't be able to use your generated LoCons or LoHas. That being said, you might be wondering, what exactly is LoCon and LoHa? They are a subset of LoRA fine-tuned modules under the LyCORIS name developed by Kohaku Blueleaf on GitHub. If you know the anime LyCORIS recoil, this test output image provided is of the character Chisato using the LoHa training method. Anyway, the methods are pretty complex to understand, so let me hop into Photoshop and show you guys this figure. Here we go. So to put it simply, LoCon or conventional LoRA seems to be an advanced form of LoRA training. And in the normal version of LoRA training, the placeholder matrices are injected right here into the cross attention layers, then trained. Just a reminder, if you forgot, self-attention is the relationship within the text prompt itself, and cross-attention is between the prompt and the image. This is the only time that the text or token embedding, this one right here, interacts with the noisy latent tensor. So these cross-attention layers right there. If we take a look at the code in Koya's ST scripts, so let me hop into VS Code now, in the LoRa Python file, you can see here in lines 39 to 47, there's the presence of these instance variables called self.LoRaDown and self.LoRaUp. In this commit about 3 weeks ago on March 6, 2023, Koya changed the logic of the LoRaDown and LoRaUp instance variables to include all convolutional 2D layers. In theory, LoCon should be better than vanilla LoRa because you're working with image tensors, so ResNet, and also the noisy latent is image information. And convolutional layers are better suited at that kind of analysis or processing. In addition, linear layers are pretty heavy and include a lot of weights. In TensorFlow or Keras, linear layers are actually called dense layers, so you can see the difference in amount of weights between that and convolutional layers. As you would expect, following what I just mentioned, LoCon is much smaller than LoRa in file size as well. For LoHa or LoRa with Hadamard product representation, it's basically a more efficient LoRa, so the file size is much smaller. You can see the results and hear my own thoughts about LoHa later in the video. Anyway, enough about the theory. How do we actually train LyCORIS modules? I'm in the local GUI or Koya SS by bMalte. If you don't know what this interface is, then please watch my previous video about LoRA for style. I'll just be going over the training settings that I used. For LoCon, I changed a few things. So right now this is the base or the default that comes with the GUI, And I'm just going to pretend that I'm doing this from scratch so you can modulate with your own settings. First, make sure you select the correct LoRA type and training parameters here. So in this drop-down window, you have 4. In the past video, I used standard. In this one, I'll be using LyCORIS LoCon and LyCORIS LoHa. So let's start with LoCon. And then, now that's enabled. Once you click on that, you can see these 2 options down here. Convolution rank and convolution alpha show up. If you go to standard, they're not here, see? So here, and then if we go to LoHa, they're also there as well, because LoHa builds off of this ResNet block LoRA that I was mentioned in the beginning of the video. Next, because I have a pretty powerful GPU, RTX 3090 and 4090, I bring the batch size up to 6, like so. I like going 20 epochs as usual, and if your computer can handle it, mix precision and save precision as BF16. After this, some things are going to deviate now. I've been trying out this new optimizer over here called DAdaptation. The default is Atom W8-bit, and this is probably the best option if your GPU doesn't have that much VRAM, but I go with DAdaptation as an experiment. And I was actually following this issue in Koya's SD scripts repository. What DAdaptation does is find the ideal learning rate as training progresses, so I just changed to that. Some other people also provided tips, such as setting the UNet to 1.0 and the text encoder to 0.5. So the logic behind that is that you want the text encoder to be half of the unit learning rate, and having the text encoder be underfitted is generally a favorable or desirable result. So I'll just go ahead, learning rate 1, UNet learning rate 1 as well, and I'll just change text encoder learning rate to 0.5. Next is the learning rate scheduler. If you watch the LoRA for style video, you know that I use constant here. So let me find it, constant. Later on, after the LoRA for style video, I changed from constant to polynomial because polynomial has learning rate decay built into it. So I changed to that. And however, for this series of experiments, I changed to cosine. And you might be asking, why don't you use cosine annealing with warm restarts? So it would be this one, cosine with restarts. Basically, what cosine with restarts is, it's a learning rate schedule that starts with a really high learning rate and then rapidly decays, and then it increased rapidly again right after. And so it's like a seesaw up and down. And I think this conflicts with DAdaptation because DAdaptation learns the learning rate on its own. So yeah, I don't recommend using cosine annealing with warm restarts with DAdaptation. So just cosine for now. Also, going on to learning rate warm-up. In the past, I used 0 with constant like this. Eventually, I switched to polynomial and 10%, and now I just use cosine and 10%. So if you want to follow along, this is what I'm using so far. Next up are network rank and alpha. In normal LoRA, I was using around 160 and 200. So this is probably what you're used to, seeing if you're used to training on vanilla LoRA. However, in LoCon, I've actually switched over to 40, like so. And I also changed convolution rank and convolution alpha to 40 as well. So one value for all 4 of these options. So I've also tried 32 as well, and after I go over the rest of these settings, I'll show you the grids for what those look like. Okay, and then lastly, let's just go back 40 and 40. And for max resolution, I've been training on 768 by 768, so I just put 800 here. Koya finds the resolution for you, so you can just put the max on each here and it'll automatically bucket all your resolutions together for you. So this is the grid. You should probably be familiar with it if you watched the previous video in which I showed how to graph epoch against strength of the LoRA. And this is the redjuice dataset that I used in the previous video as well. So it's a good baseline to see what's going on. As usual, the objects of interest are in this bottom right quadrant. So if we zoom in and look, it's pretty cool actually. There's very interesting results. However, I felt that the face and the anatomy was ruined more than usual. And just for example, we can look in this bottom right on the last row. This is not right. This is too far out here. Like that. Yeah, these are all not right. The face is weird. And in addition, I felt that it was more unruly to use when compared with that of the 40 dimension LoCon. So what I mean is that when I tried to prompt for something, it often got very chaotic and I had to look through all these results to find the more clean objects. And even so, this is still very chaotic. The shapes meld together too much. So yeah, that was one issue I found with using the 32 dimension LoCon. Here we are in the 40 dimension LoCon, and let's go ahead and take a look at the bottom right quadrant. So here we go. You can already see that it's quite clean here, very clean. Keep going. Let's just zoom out a little and see these. So there aren't any glaring anatomy issues, I would say. The face also looks fine. These are all like okay. With enough inpainting, you can fix these up. And if we decrease the strength a little, yeah, this is very nice. And it was also easier for me to prompt for this. So if I want to change the hair color, it'll change. If I want to change the wings to another color, or I want to change the design of this armor to something else, very simple. Lastly, let's take a look at the vanilla LoRA. So this is not LoCon or LoHa, not LyCORIS at all, just the original 180 megabyte file. And once again, go to the bottom right quadrant. Yeah, not bad. Not bad. There's some issues going on here. Resolves themselves. And then we get to this image here, the last one. I don't know how you guys feel about it, but I feel like this is still very good. And it might even be the best one, artistically speaking, this one. We can compare, go back here, you can look at the last one. I mean, it really depends on what you like, but obviously 32 is the worst. I think there's no doubt about that one, even though it is the coolest. Yeah, these designs are very cool. So it's really up to you. I wouldn't say it's a significant improvement over vanilla LoRA, but it's really up to you. If we go back and look at the recommended settings on Kohaku Blueleaf's GitHub repository, it says for LoCon or conventional LoRA to use network dimensions of 64 or less, and then an alpha of 1 or less. And for LoHa, or this part, second part, it says to use dimensionality or rank that is a square root of what you used previously, and also to have a alpha of 1 and lower. But if we go back and take a look at the GUI, I'm actually using pretty high numbers for the convolution rank and convolution alpha. In addition, some people have recommended that your alpha should be 1/2 of your rank. I actually tried this and I could not end up generating any images. It just gave me noise. Or first it gave me this, you must enable no half VAE or something. So I did. And then when I generated, I got latent noise. So I'm not sure what other people are using, but half of dimension for alpha did not work for me. Just putting that out there. In addition, there's a link about DAdaptation on GitHub, and there's an explanation here saying that the smaller the alpha is relative to that of the dimension, the smaller the subgradient is. Smaller subgradient makes the learning rate higher, which destroys the model. So it seems to prove my experimental result, which is that higher convolution rank in alpha should yield better results. And that's what I was happy with in the end. Next is LoHa, and it's more or less pretty similar. So go over here and change to LoHa. And the only thing that I changed are the network dimensions and the convolution rank. So these will be 14 and 14. Previously, I used 160 for vanilla LoRA, and if you want to go with the square root of that, it's around like 12 something, but I just bumped it up to 14 for good measure. And for convolution rank, I use 4 and 2 or 4 and 1. So that's it for the settings, and now I'll show the grids for 4 and 1 and 4 and 2. So let's get to it. So this is the grid for convolution dimension 4 and convolution alpha of 2 dimensions. If we go to the bottommost row and take a look, the outputs are pretty aesthetically unpleasing or displeasing. They look very bad, I would say. They slightly resemble redjuice's style, but not so much. And if we take a even closer look, after epoch of 8, everything becomes kind of disastrous. I could probably salvage some of these if we keep lowering or decreasing the strength. I could probably do something here, but yeah, I would still say that this is not usable. So that being said, let's go over and take a look at the other grid. This is the grid for convolution of 4 dimensions and alpha of 1, not 2. So once again, let's take a look. Yeah, this is pretty cool, I would say. But yeah, it's still not fully baked in. Let's just keep going. Yeah, it's not baked in yet. Keep going. Kind of, we're getting there. This is close. This is also close. Fine. And then all of these are no good, I would say. If we decrease the strength and go to the ones above, these are, I would say they're acceptable. They're okay. So there's more usable information here compared to that of alpha rank of 2. So once again, I've kind of seen from the experimental results that having your alpha be half of your network rank to be kind of disastrous, to be honest. So there you go. After conducting quite a few experiments and analyzing the grid results I showed previously, I more or less have a decent idea of what values will work for training a LoCon and a LoHa. So to put that information to the test, I've created a new dataset using the artworks of SWD3E2. If you're not familiar with SWD3E2, what a mouthful to say. He or she is a Chinese artist. Just for some context, this artist is widely known as a Pixiv Fantasia legend. So if you don't know what Pixelfantasia is, it's basically this kind of role-playing event on the Japanese site Pixiv where you join a make-believe faction and then create artwork based on whatever faction you joined. So there's quite a few here. The first one I participated in was Fallen Kings. So this one, Pixelfantasia FK. And I think I was part of this one, this faction, Emberland. Yeah. Anyway, so a fun fact is if we go back to SWD32's artwork here, there's a piece here from one of the Pixelfantasias which came after, which is called Last Saga. This is one of the pieces that made me actually want to become serious about artwork or becoming good at art. And even now, I still come back and look at it from time to time. I just really enjoy this kind of aesthetic. Yeah. So we'll be training on this dataset, and I'll be going over a different method of captioning, which I think will streamline your workflow quite well. For the captioning process, I'll be using this tool called the BooruDatasetTagManager. It is recommended to me by you guys in my previous LoRA for Style video, and since then I've incorporated it into my workflow. To download it, just go to the releases right here and click on this link for latest, and you have your zip file. So just download this and unzip it. So once you open up the Dataset Tag Manager, you're greeted with a lot of nothing here. So what do we do? Well, it's very easy. First off, remember that I've already gone through, renamed all the images so they have the same name. And then also I've cropped them down to the resolution I like to work with, so 768 square pixel. So go over to File, Load Folder, and choose the folder where your images are. So for me, it's at that path. And you can see all my images are loaded in here. And there is a problem though. We don't have any captions yet. So what do we do? So first we have to go to the automatic web UI and generate some captions. In the automatic 1111 web UI and on the tagger extension tab, this should be very familiar to all of you if you watched the previous video. So batch from directory, paste your path, and then I usually paste the same path here because I want my captions to be in the same folder as the images, and just interrogate. Very simple. And if we take a look at the command line or command prompt, it's doing its thing. And if we look at the folder, it's actually also doing its thing. Very cool. Real-time captioning. So the captions are done, and yes, the captions are here. So let's head back to the Dataset Tag Manager. As you can see, I have the old folder loaded in. And if I just load the folder one more time, so load folder, like so, select it, you can see that captions have appeared now. So how exactly do we use this software? So first of all, I want to open up this view and then show preview so I can see my image here, like so. Great. And then if I look at the tags here, these are all the tags that belong to this image. So just look and see and caption all the things that you don't want or all the things you want to change. So everything that remains is the style. So yeah, this looks fine to me. Next one. Okay, so this one has suture from Arknights. I don't think this is suture. So if I want to remove it, I'll just click on it and then press X. We no longer have to go in to VS Code and delete words and add commas and all that stuff. And also one thing I noticed is that there isn't a floating in the air tag here. So I'm just going to click somewhere, click on the plus sign, double click here, and just add a floating in the air. Floating in the air, like so. The cool thing is that if I add this tag here, floating in the air, and then I refresh the tags here, you can go down here and see that floating in the air is actually here now. So if I want to reuse this tag in the future, great. And remember when I was tagging for style in the previous video, remember that you have to remove all references to character names because you don't want those to be associated with the style. So just go through the tags on the right and look for character names or races or species, that kind of thing. So Admiral Graph from Azure Lane, we don't want that. So click on that, then press this X. It's removed from all the tags. And let's keep going. Cheetah, Grand Blue Fantasy, yeah, we don't want her. Sorry. We don't want Draft because Draft is from Grand Blue Fantasy as well. Emilia, no, we don't want that. So just go through all the tags on the right and just remove all character names. So Unicorn, Azure Lane, I don't know who that is. Okay, so that more or less covers how to tag or how to use this. And once you're happy with the tags you have, just go to File, Save All Changes, and it's saved. And let's just go ahead and look at this folder. So let me pull this over here, paste that in, and remember how I added floating to the air or floating in the air to this one. So it's the second image. Let me find it, open this up, and see floating in the air is here. Great. So our software or our knowledge of how to use the software is growing. Lastly, if we want to add a tag to everything, this is probably not that useful for style captioning, but if you wanted to caption for a person, you can go over here to the right, add a plus mark, and you can add a tag of whatever you want. So if I wanted to tag for a person, so KSK, I don't know, kasukanra, you can add it to all the tags here, and you can choose the position. So if you want it to be at the top or the very last tag, or you can add a custom position. So if you put custom 1, it'll be the second tag and everything. So do that. Every single tag now has this token I added. Pretty cool, right? So there you go, a crash course on using DatasetTagManager. So I finished training using several different parameters, much like the earlier redjuice style model training. Then I generated the same epoch versus weight grids, once again while keeping my prompts relatively the same. So this first grid you see here is LoCon with dimensions 40 on everything. So network, alpha, convolutional network, and alpha. So as you can see, it starts off pretty not so good. I would say it's quite poor actually. And then in the later epochs, it starts to take on more of the style, like so. And eventually at the end, you get things like this, which is, I would say it's very nice. If you told me that SWD3E2 illustrated all of these, yeah, sure, I believe it. It really looks like that style. Okay, so now we see the power of LoCon. Let's go ahead and look at the LoHa grid. This is the LoHa grid with dimensions of 14 for both network and alpha, and for the convolutional dimensions it's 4 and the convolutional alpha is 1. In the same vein as the analysis of redjuice's style LoHa, I remain unconvinced. Yeah, you can see the progression. So these are the earlier epochs here. These, and then if you keep going. Yeah, so this is the end. It's okay, but for me, I would say it's unusable still, even for my own use cases. Maybe you feel differently, as we all have our own aesthetic taste, but LoHa does not seem to meet the eye test for me. That being said, since I have a bit more life experience, I almost always look towards myself as the point of failure and potential error. So I wondered, perhaps I should switch the optimizer and learning rate back to something more normal. Right now are the settings for the LoHa I showed in the earlier section. So the LoHa for SWD3E2's images that I said weren't that great. And so what I did was I changed from DAdaptation back to Atom with 8-bit, and then changed these learning rates back to a different learning rate. So if you recall, the default learning rate is this, so 1 times 10 to the negative 4, and the text encoder learning rate is 5 times 10 to the negative 5. So roughly the text encoder learning rate is half of the unit learning rate. And I tried these settings initially, but my LoHa didn't really end up reaching the final style. So I had to raise the learning rate a little bit more. So what I ended up using is 3 times 10 to the negative 4. And then for the text encoder, I use 1.5 times 10 to the negative 4. The last thing I changed is I turned the convolution alpha up to 2. So these were my settings for the second LoHa, which I am now about to show you. So this is the second LoHa grid, and it's using the more classical settings, so Atom with 8-bit, and actually fixed initial starting learning rates, none of that DAdaptation, witchcraft. And let's first take a look on the initial stages, the earlier epochs. It's fine, I would say. Like, these look okay to me. And then you keep going slowly. And this is the final results. I would say they're better. They're more representative of the style. These two, just anything here too, are better, but I'm not sure. It's really up to you. And I found that LoHa destroys the anatomy pretty hard. So you can see that this person is missing half her body. Yeah. Even with these more concrete settings, I'm still on the fence about it. Back in Koya SS GUI, and these are the previous LoHa settings with the Atom optimizer. After so many exhaustive experiments, I felt a little discouraged that I still hadn't found optimized hyperparameters for LoHa. The last thing that I didn't attempt was to make the convolution dimensions in alpha the same value as the network dimensions in alpha, similar to the LoCon experiments. So what I did was to change these convolution ranks to 14 as well. And I also reverted back to the DAdaptation optimizer and changed these learning rates accordingly. So these are the settings that I ended up using for the final LoHa experiment. This is the grid for the final LoHa experiment where all the ranks or dimensions are the same. So if we look more closely, even on epoch 8, it still hasn't converged. Keep going. This kind of resembles the style. I would say this is close. And then we keep going and it starts going crazy. The anatomy is being destroyed so much here. It kind of recovers, so that's a good thing. And then I would say it's really off here. Like no legs, torso too wide, face broken, no legs, no legs. Yeah. So I did end up finding a pretty cool image through this entire grid, and it's this one. Yeah, it's kind of decent. I would be okay taking this into ZBrush and sculpting it, or using this as an idea, but for an illustration, it needs a lot of in painting in this area. So yeah. As always, all the models are available on Civet AI, so the proof is in the pudding. In my opinion, I would say LoCon is better than vanilla LoRA, but not in image quality. I would say the image quality is pretty comparable between the two of them. However, LoCon feels like it understands prompts better and also adds some artistic flair, at least in the case of style. In addition, LoCon has a smaller file size relative to that of vanilla LoRA, so this is probably great for all you optimizers out there. Unfortunately for LoHa, I can't recommend it in its current state as I'm personally not very happy with its results. However, my experiments are not thoroughly exhaustive, so it's highly probable that superior parameters exist, and I haven't found them yet. So feel free to experiment. I just want to offer up what settings I've been using, and you're all free to improve upon it, as is the way of science. So there you have it, a small update to the LoRA for Style video. Once again, thank you all for watching, and I hope this was illuminating. See you in the next video. Bye! Before I forget, this channel has a Discord server now, so feel free to join. In addition, training datasets will be available on Patreon. If you become a patron at any tier, you'll get access to all the datasets and project files I choose to release.